endocrine glands. Okay, these are the 7. So like 8 or 9 glands that you guys have to know that belongs to the endocrine system.
No.
Now this is obviously not all the endocrine glands or types of tissues that has endocrinic activities or endocrinic abilities, right? The other ones you guys should already know. That includes that. Okay, so from the hypothalamus, you have 2. Supraoptic nucleus releases ADH. Okay. ADH goes to collecting duct, kidneys, and increases water reabsorption. Another one is your paraventricular nucleus. Releases oxytocin. Oxytocin goes to uterus. Mammary glands. One else, 2 else.
I think one
right. Oh, whatever, right? Okay. So at the uterus, it causes labor and delivery, or induces labor and delivery. Orgasm. Okay. At the mammary gland, increases milk ejection. There's a 3rd nucleus here called the suprachiasmatic nuclei. And from the hypothalamus, that is going to go to the pineal gland. It causes the pineal gland to secrete melatonin. Melatonin controls your circadian. Okay. So, 1, 2. Okay. So this is just a very fast list, but remember, these 2 originates in the hypothalamus and extends their axons all the way to the posterior pituitary gland. Okay. All right. From the hypothalamus, you also here. You also release. It's known as TRH. Okay, thyrocortical thyrocorticotropin releasing hormone. TRH will go to the anterior pituitary. So this, we can just call it anterior pituitary. It causes the anterior pituitary to release TSH. TSH goes to the thyroid gland and stimulate the follicular cells of the thyroid gland to release T3, T4. T3, T4 goes to tissues of the body and increases metabolic activities. That's all you guys have to know about those. All right. Another hormone from the thyroid gland. I saw the hypothalamus. You would have the CRH, corticotropin releasing hormone. Okay, CRH in there goes to the adrenal cortex. Okay, stimulates the adrenal cortex to release ACTH. Oh shoot, no, sorry. Anterior pituitary first. Let's get back to the these arrows are confusing, huh? ACTH then goes to the adrenal cortex, and the adrenal cortex will release 3 different hormones. The first layer of the adrenal cortex is called the zona glomerulosa. That's going to release your mineralocorticoids. This is otherwise known as your aldosterone. Aldosterone goes to, where does it go to? This will come through the tubules of the kidneys, and that induces increased anti-sodium chloride water reabsorption. Second layer, it goes to, it releases glucocorticoids. Otherwise known as cortisol. Cortisol then will go to the liver, adipose tissue, skeletal muscles. So at the liver, it induces glycolysis, which is breaking down glucose from glycogen molecules to release those glucose into the circulation, and also induces gluconeogenesis, making new glucose molecules from a non-carbohydrates or non-glucose source. At the adipose tissue, it increases lipolysis, breaking down fatty acids. Skeletal muscle, it also do all this stuff, but also increases protein metabolism. Probably does protein metabolism at the liver also. Because the liver makes a lot of your proteins, your blood proteins. Okay, so that's cortisol. Third hormone that the adrenal cortex releases is called androgens. Androgen will go to the gonads and help stimulate the development of the gonads in conjunction with the primary sex hormones and things like that. All right, that's the adrenal cortex.
So does it do anything when you develop and become an adult?
Yeah. Yeah, so it helps also to develop secondary sexual characteristics, like your voice being lowered and all the other good stuff that goes with puberty. Okay, so third hormone is hypothalamus. Release. This one is called gonadotropin releasing hormone. Gonadotropin releasing hormone goes to the anterior pituitary. So I'm just going to put it right here. And the anterior pituitary releases FSH and LH. Okay, under the stimulation of gonadotropin releasing hormone, which is G(NRH). FSH and LH collectively will go to the gonads. Stimulates the gonads. If you're female, it stimulates the ovaries to secrete estrogen and progesterone. If you're male, it stimulates the testes to release testosterone. All right. Hypothalamus also releases GHRH, which is growth hormone releasing hormone. Growth hormone releasing hormone goes and stimulates the anterior pituitary here to release growth hormone. So all these belong to the anterior pituitary. Growth hormone does not go to any of the other endocrine glands. What it does is it go to the body. It will go to the liver. Go to tissue. It'll go to skeletal muscles. So because it's a growth hormone, it wants to break down a lot of glucose, so it increases glucose metabolism. Increases lipolysis. Increases glucose metabolism here too. Increase glucose, also increase protein metabolism. Basically everything you need to do to grow also goes to the bones. Increase length. Of the skeletal system. Technically, growth hormone doesn't go to any of the other places except for the liver, which will induce the liver to release a different type of hormone called insulin-like growth hormone. But that's just something extra you guys don't have to know. Okay. Hypothalamus also release somatostatin. Somatostatin goes to the anterior pituitary and inhibits the release of growth hormone. So once you're done growing or whatever, you don't need any more growth hormone to be released from the anterior pituitary, and somatostatin released from the hypothalamus will make sure that it inhibits the anterior pituitary from releasing growth hormone. There's another hormone from the hypothalamus called prolactin inhibiting hormone, or PIH. What PIH does is it will go to the anterior pituitary and inhibits the release of prolactin. Okay. Now usually without PIH, prolactin will go to a couple of different sites. Okay, well actually just one. Its targets for prolactin is the mammillary glands. Okay. So it goes to the mammillary glands to increase milk production. So as you can tell, prolactin and oxytocin kind of works together. Okay. One is to produce the milk, one is to help eject the milk, okay, for successful breastfeeding. All right, so a couple of hormones, TRH, here we see RH, GnRH, GHRH, somatostatin, and PIH. Okay, those are all coming from the hypothalamus. Here you have TSH, ACTH, FSH, LH, GH, and prolactin, which is coming from the anterior pituitary. Okay. All right. Now, with the adrenal medulla, we know that this is sympathetic activities, which induces the adrenal medulla to release epinephrine and norepinephrine. Okay. And that goes into the blood and goes to the system to increase systemic sympathetic activities. Okay. Got the pancreas. Okay, so I'm going to move these two over here. So I'm going to put thyroid on thyroid gland. Thyroid gland. Pancreas down here. So keep in mind, the pancreas should belong on that list too. Okay, so if you have an increase in calcium blood level, that is going to induce or stimulate the thyroid gland, specifically parafollicular cells. of the thyroid gland. Okay. This is going to release calcitonin. Calcitonin goes to the kidneys. Because you have an increase in blood calcium level, it goes to the kidney and it increases the secretion of calcium into the urine. It also goes to the bones. And because you have an increase in calcium in the blood, you want to store the excess calcium ions. Okay? So you're going to induce the activity of osteoblast. So you're going to increase bone deposition. Okay? By increased osteoblastic activity. So you make more bone matrix. Now I mentioned the GI tract, but don't worry about the GI tract in terms of calcitonin. All right. So you have a decrease in blood calcium level. That is going to stimulate the parathyroid gland to secrete parathyroid hormone. Okay. And because there's a decrease in calcium level, parathyroid hormone will go to a couple of different sources. One goes to the intestines and tell the intestine to increase calcium absorption. Two goes to the distal convoluted tubules of the kidneys and tells that to increase calcium reabsorption. And it goes to the bones and it increases osteoclastic activity to increase bone resorption by increased osteoclast activities. Right. Essentially doing these three functions at these three targets increases calcium to be released into the blood to raise this blood calcium level back up to normal. Okay. Now the pancreas has two different types of cells. One's called the alpha cell, the other one's called the beta cells. Okay. Alpha cell releases glucagon, beta cell releases insulin. Now what triggers these cells to release their hormones is a differential levels of glucose inside the blood. If you have a decrease in blood glucose, that's going to trigger the alpha cells to release glucagon. Okay? Because you have a decrease in blood glucose, you want to go to the source that stores the most glucose, so it goes to the liver. And it tells the liver to increase glycogenolysis, breaks down of glycogen into glucose molecules to liberate those glucose molecules back into the circulation. Excuse me. Also goes to the adipose tissue. So the adipose tissue to increase lipolysis. Some of these fatty acids may be taken back into the liver to make new glucose molecules. I don't know if it goes to the skeletal muscle or not. Just leave that at that. So both of these, specifically at the liver itself, that's going to liberate a lot of glucose molecules to increase this glucose concentration inside the blood, right? So for insulin, for the beta cells, if you have an increase in blood glucose, that's going to stimulate the beta cells to release insulin. And it's going to go, again, to the liver. This is going to increase glycogenesis. Okay. Which means it's going to take up this excess glucose and stick it into a glycogen molecule to expand that glycogen. 2, it's going to go to the adipose tissue and increase fatty acid deposition. And then go to the skeletal muscles to tell the skeletal muscles to also take up these excess glucose, either use it as energy, so increase glucose metabolism, or again, increase glycogenesis. So, calcitonin, parathyroid hormone, glucagon, insulin. You have aldosterone, cortisol, androgen. And at the ovaries, you have estrogen, progesterone, and testosterone. And that's it.